So I'm given a point. I'm given the point radical 2 comma 4. And that is on the terminal side of angle theta in standard position. And I have to give you the 6 trigonometric functions of this angle. So I'm going to draw a picture. What quadrant is radical 2, 4 going to be in? It's going to be in the first quadrant, right? I don't know exactly where it is. It's going to be over here someplace because they're both positive. Is everybody okay with that? Okay. So again, I don't know what it looks like. I know radical 2 is smaller than 4, so I'm just going to, it doesn't really matter where I put it. I'm just putting in an angle there so I can have something visually to see. You might not need to do this. I need to do this. So if I put in my angle there, and I know that this point is on the angle, and that point is radical 2, 4. And my angle is looking like that. That is my angle. That's the terminal side. Here's the initial side. The x-axis going positive is always the initial side. My terminal side is going to be right there because I know that point's right on it. It's in standard position, meaning that my vertex is at the origin. So that's letting me know how I'm supposed to draw this angle. And the values of this are radical 2, 4. So that means this distance here is radical 2. And it means this distance here is 4. Is everybody okay with that? So I do not have a unit circle. And you should be able to tell right away that it's not going to be a unit circle, because a unit circle, the hypotenuse is 1, right? And certainly any triangle that I'm going to draw, any right triangle that I'm going to draw, the hypotenuse has got to be the longest side, correct? Right, well, I already have a side here that's longer than 1. 4 is longer than 1, so I know this is not going to be a unit circle. Okay. So it's not going to be a unit circle. It means that I'm going to have to use SOHCAHTOA to find my trig values, because I'm going to have to worry about what the hypotenuse is. When it's a unit circle, I don't need to worry about what the hypotenuse is, because the hypotenuse is 1. But when it's not a unit circle, I have to worry about the hypotenuse, because I have to divide my opposite by the hypotenuse or my adjacent by the hypotenuse. Any question on that? Is that okay? Okay. Yes, please.
Are we using the Pythagorean theorem now?
Now we have to use the Pythagorean theorem, because I have to find out what my hypotenuse is. If I want to be able to find sine or cosine, I have to know what h is. I have to know what my hypotenuse is in order to find out what the ratio is. If I don't know what the hypotenuse is, I can't know what the ratio is. So the immediate inclination is to be really happy and look at this. So this one's easy, right? Because I have, well, radical 2 is my cosine, 4 is my sine, and this should be easy. If 4 is my sine, then cosecant should be 1/4, right? No, doesn't work that way, because this isn't sine or cosine. The x and the y values are only sine and cosine when we're dealing with a unit circle.
I have a question.
Yes.
Angle theta is the little one, right? Like the one that's like near the vertex?
This is angle theta right here.
Yeah, because that's like the little, yeah. Okay.
Right. Well, that's my angle because and that is also my reference angle.
It's the terminal side thing.
That's right.
Okay.
That's right. That's right. Okay, so I need to now find out what is the length of my hypotenuse. And I'm going to find the length of my hypotenuse by using the Pythagorean theorem. So I have my two sides, radical 2, and the other side is 4. So I'm going to go radical 2 squared plus 4 squared is equal to hypotenuse squared. Everybody's okay with that? Thank you, Pythagoras. Okay. So radical 2 squared is 2, plus 4 squared is 16, is equal to hypotenuse squared. So I have h squared is equal to 18. I will take the square root of both sides. And I don't need to worry about plus or minus here because I'm dealing with distances. So I have h is equal to the square root of 18. And I see a 9 in there, and a 9 is a perfect square. So I know h is equal to 3 radical 2. So now I have my hypotenuse. Hooray. My hypotenuse is 3 radical 2. Yes?
Does it matter which angle is theta? Like, out of the two angles, does it matter which theta is?
I'm not sure I understand your question.
Yeah, you have to put the reference angle. Oh, okay. Thank you, Nicole answered.
Okay, good. For
But you could have done that because we know the ratio is 1 and then half of that, like in the 1, 2, 3 square 2 triangle, right? Because 2 to 4 is the ratio of 1 to 2.
You're losing me here. You might have a better angle than I, better idea than me. What are you saying now?
Because we know that in that one, in the special triangle, the ratio of the angles, or of the sides, is 1, 2, 3 square root 2.
Yeah.
So we are.
But we know 1, 2.
Never mind, because it's square root of 2, not.
It's not 2 radical 2.
Right.
Yeah. So this is not a special triangle as far as I can tell.
Okay.
Yeah. If the point that I was given had a radical 3 over 2 and a 1/2 in it, well then I would know that it was a special triangle. But I don't know that. Okay. Okay.
All three triangles don't, because it's not 30, 60, 90.
Not 30, 60, 90. Right. I don't know. It's just
Oh, right.
it's just angle theta. So I don't know what angle theta is yet. Okay. We'll know what angle theta is on Monday, next Monday. We'll be able to figure that out. Okay. So sine. Let's do here. Let's put our little Let's go. Sine, cosine, tangent, cosecant, secant, cotangent. And you'll notice on my the worksheet that I did, what I do is I know that I'm going to have some radicals here that I'm going to have to rationalize. So I just kind of put a little line and I'll do my calculations below so that my answers can be nice and, listen carefully, answers can be nice and neat, right? So they're all I can see immediately, that's what they are. Yeah, you don't have to do that, but boy, it sure would be nice if you did. Okay, so sine is going to be, here's my angle theta. My side opposite theta is 4. And my hypotenuse is 3 radical 2. So sine, I'm going to do that in my little calculation area here. Sine.
Excuse the introduction. Is Emily Fabulous from office?
Yes.
Thank you.
So sine is going to equal to 4 divided by 3 radical 2. So sine is 4 over 3 radical 2. And I have to do a little bit of rationalizing to find out what this is. So in order to rationalize, I just need to multiply the top and the bottom by radical 2. I don't have to multiply it by 3 radical 2. The only thing I'm trying to get rid of is the radical sign. So I just need to multiply it by the radical 2 that's on the bottom. Is that okay? Okay. So this is going to give me 4 radical 2 over 3 times 2, which is 6. So this is going to give me, I can make this in 2. This is going to give me 2 radical 2 over 3. That's my sine. Great. So here's sine. What was it again? I forget. 2 radical 2 over 3. 2 radical 2 divided by 3. Okay. My cosine is going to be adjacent over hypotenuse, which is radical 2 over 3 radical 2. So cosine radical 2 over 3 radical 2. And that's really nice because I can just get rid of my radical 2's. So cosine is going to be 1/3. Cosine is going to be 1/3. Tangent is going to be sine over cosine. Now you'll note, my sine and my cosine have the exact same denominator. That means, let's just, it means all I'm concerned about is the numerator.
I could have done that, all that was.
So yeah, there's a lot, like if it's 2 radical 2 over 3, so it's 2 radical 2 over 3 divided by 1/3. I mean, yes, I can take the long way, nothing wrong with taking the long way, and multiply the bottom by its reciprocal, right? That counts out to 1, and then my denominators, my 3's cancel out, so I'm left with radical 2 over 1. And I could have done that the exact same way as just looking and seeing, since they had the same denominator, all I'm really concerned about is the numerator. If you're not clear on that, don't do that. Do it the long way. Yes?
Okay, so I have a question. Like for me, like I think it's kind of hard to put the fraction over the fraction. So I just put the opposite over adjacent, which is like the same thing. Isn't it like cosine? Because then you have like a fraction.
It's fine. It's fine. That's fine. Opposite over adjacent is fine. Yeah, that'd be fine. Okay, so I get my tangent as being 2 radical 2. So my tangent is 2 radical 2. My cosecant. So cosecant is the reciprocal of sine. So I could take this and flip it over and then rationalize my denominator all over again. But you know, in my calculations here, I started out with sine being not rationalized. One of the nice things about it being not rationalized is that now when I flip, I can just take that and flip it right over, and I have 3 radical 2 over 4. Yeah, Julie.
-4, so wouldn't it be -2 radical 2?
No, it's not a negative because look at our quadrant.
But the given point is radical 2 over -4.
Did I make a mistake?
Like no, nothing changes besides it's negative.
That's all that changes. Yeah. I wrote the problem wrong. Okay, but so we're doing this problem instead, right? We have a whole extra problem that we get to do, right? Okay. Yeah. So really, this angle, you're right, Julie. This angle should have been over here. No, it should have been. Yeah, right. It should have been over here. It should have been in quadrant 4, not in quadrant. So good catch. Good catch. But we're doing this problem.
Okay.
Yes, I planned it that way. Okay. So cosecant, I just kind of go back here to my sine, and I have 3 radical 2 over 4. I just take the reciprocal of that. So I have 3 radical 2 over 4. My secant is the reciprocal of my cosine. There's nothing to rationalize there. So my secant is going to be 3. And my tangent is going to be, let's see, what do I have as tangent here?
2 radical.
Radical 2 over 4.
I have to look now. So my tangent is going to be, so I would actually have to sit there and calculate. So my tangent is going to be cosine over sine. So it's going to be, my tangent is going to be, the tangent is going to be 1/3 divided by 4 over 3 radical 2. Oh, is that right?
You mean the cotangent?
Yeah, cotangent.
Yeah.
Right? So I'm going to multiply both sides by 3 radical 2 over 4. 3 radical 2 over 4. This is going to go away. I'm going to get, that 3 is going to go away, so I'm going to get radical 2 over 4 for my cotangent.
Alright, can you scroll back 1 for 1 second?
I certainly can.